Let's practice verifying a trigonometric identity together. In this particular problem, on the left side we have the quantity of cosecant of theta plus cotangent of theta, that's all being squared, and that's going to be equal to this quotient. We have 1 plus cosine of theta over 1 minus cosine of theta. To go ahead and verify that the left side is indeed equal to the right side, I'm going to go ahead and rearrange the right side of this equation to make it look like the left side of the equation. First, I'm just going to go ahead and copy down the right side of this expression. So we have 1 plus cosine of theta, and that's going to be on top of 1 minus cosine of theta. And once we have this original expression, what I'm going to go ahead and do here is I'm going to multiply this entire expression by 1. Now, while there's many different versions of 1, I'm specifically going to use something called the conjugate. So I'm going to multiply this by 1 plus cosine of theta on bottom and 1 plus cosine of theta on top. So we're using the identity property, but again, 1 plus cosine of theta over 1 plus cosine of theta is just equal to 1. Now I'm just going to go ahead and put parentheses around each of these parts so we don't get a little bit confused, and we know that we are going to have to distribute or FOIL or go ahead and multiply each of these terms by each other. All right, multiplying this 1 by 1 on top, that's just going to equal 1. Then we're going to go ahead and take this 1 on top and multiply it by cosine of theta. That's going to be plus cosine of theta. Following that, we're going to take this cosine of theta and multiply it by 1. That's going to be another cosine of theta in the middle. So we're going to have two of those that we can combine in just a moment. Then we have cosine of theta times cosine of theta. That's going to be just cosine squared of theta. All right, so that's going to be our numerator there. Now let's go ahead and multiply the bottom, but notice that we have a difference of squares pattern. So it's going to be 1 minus this cosine of theta and 1 plus cosine of theta. So that's specifically why we're multiplying by this, because we're going to see some nice things cancel out here. So 1 times 1, that's just going to be a 1 in the denominator. And then if we go ahead and multiply this 1 times this plus cosine of theta, again, that's going to be plus cosine of theta. Then multiplying this negative cosine of theta by 1, that's going to be negative or minus cosine of theta. And then finally, negative cosine of theta times positive cosine of theta is going to be negative cosine squared of theta. Now let's clean this up a little bit. In the numerator, we have this cosine of theta plus cosine of theta. So I'm going to rewrite that as 1 plus 2 of these cosine of thetas, plus we have another cosine squared theta at the end there. And then in the denominator, let's go ahead and combine. We have a plus cosine of theta and a minus cosine of theta. So of course, with difference of squares, they should cancel out. So we just have 1 minus this cosine squared of theta in the denominator. All right, next, if you take a look at this 1 minus cosine squared theta in the denominator, let's go ahead and see what that's going to be equal to. So hopefully this is a little bit familiar. If you know your Pythagorean identities, then you know sine squared of theta plus cosine squared theta is equal to 1. So if you go ahead and take away cosine squared theta from both sides, you'll then see or know that sine squared of theta is just equal to 1 minus this cosine squared of theta. Now, if that's the case, we can go ahead and make a substitution here, and we know that sine squared of theta is equivalent to this 1 minus cosine squared of theta. So if these two are equivalent expressions, we can go ahead and swap this 1 minus cosine squared of theta out for the sine squared of theta. So let's just go ahead and take this entire top and keep it the same, and just write sine squared of theta in the denominator. All right, now let's go ahead and separate this into a few different fractions. So instead of writing it as one big fraction here, I'm going to rewrite this as 1 over sine squared of theta plus, I'm going to write 2 times cosine of theta over this sine squared of theta. Okay, two separate fractions, plus a third fraction here, and I'm going to write cosine squared of theta over this sine squared of theta. Now next, we're going to go ahead and see if we can rewrite this without using a fraction. So again, if we know our reciprocal functions here, 1 over sine is cosecant, so 1 over sine squared is going to be cosecant squared of theta. Now that we know what this is going to be written as without a fraction, let's go ahead and try our next part or our next term. So looking at this 2 times cosine of theta over sine squared of theta, I'm actually going to pull that off to the side because that one's a little bit trickier to understand. So for this term, I'm actually going to rewrite this as 2 times cosine of theta on top of, and I'm going to separate the sine squared of theta and just write sine of theta multiplied by sine of theta, right? That's an equivalent expression here. Next, I'm going to go ahead and see if we can rewrite this a little bit. So I'm going to rewrite this as 2 over 1 multiplied by cosine of theta over sine of theta. and I'm going to multiply this by 1 over sine of theta. So just kind of rewriting this into 3 pieces here. Now, if we just take a look at what is cosine over sine, well, remember sine over cosine is tangent, so cosine over sine is just going to be cotangent. So this is going to be 2 in the beginning multiplied by cotangent of theta. Okay, and then if you take a look at this 1 over sine of theta, similarly to earlier saying that 1 over sine squared of theta was cosecant squared of theta, then 1 over sine of theta is just going to be cosecant of theta. Now taking this entire thing and making that substitution back into our expression. So substituting that in, we're going to write plus, and this is going to be 2 multiplied by cotangent of theta multiplied by cosecant of theta. That would be this middle term rewritten, but without a fraction bar. Next, let's take this cosine squared theta over sine squared theta, and let's go ahead and rewrite that without using a fraction. So if we knew cosine over sine was cotangent, then cosine squared over sine squared is just going to be cotangent squared. So I'm going to write plus cotangent squared of theta. That's going to be this third term. And again, this time it is not written as a fraction. All right, now this looks pretty complicated, but hopefully I can show you what to do next with this piece of information on this line. So for a moment here, let's go ahead and say, let's let x equal this cosecant of theta, and then let's let y equal this cotangent of theta. Just for a moment here, so just bear with me. I know I'm kind of doing something a little bit strange here. So if x is equal to cosecant of theta, then what's cosecant of squared of theta going to be? That would be x squared, right? Because it's multiplying it by itself. Plus, and then we're going to have 2 of these what? So it's 2 times cotangent of theta times cosecant of theta. But if that's going to be x and this is going to be y, this is going to be 2xy. And then finally, if we have cotangent squared of theta, that's going to be substituted by y, so that's going to be y squared. So hopefully this looks a little bit simpler and looks maybe like something you've seen in the past with quadratics. This is called a perfect square trinomial. So when you graph it, it touches the x-axis. It doesn't go through it when you're graphing quadratics or parabolas. And also when you factor these, they factor very nicely. So this is going to factor into the quantity of x plus y times the quantity of x plus y, or also known as the quantity of x plus y squared, right? So in simplistic terms here, that's what that would look like. And if you go ahead and reverse make that substitution, remember this x is really cosecant of theta and this y is really cotangent of theta, then you should be able to expand this back to what we were having initially and say this is going to be cosecant of theta plus cotangent of theta. It would be that entire thing squared. Now, why does any of this matter on the side? Why did I go on kind of that little side story? Well, if you go ahead and look over at the left side of the problem, you can actually see here that this cosecant of theta plus cotangent of theta, we actually have that quantity squared, and that's actually what we just got. So hopefully knowing a little bit about quadratics helps out here. And so if we go ahead and factor this, right, and keeping this all using our trig functions, then this is going to be cosecant of theta plus cotangent of theta multiplied by that same exact replica. So we have cosecant of theta plus cotangent of theta, 2 of these. And if you want to go ahead and FOIL that out, feel free to do so. But then hopefully you can see, because we have 2 of these identical pieces that are being multiplied by each other, we can then just condense this and say we have this quantity of cosecant of theta plus cotangent of theta, and that's that entire quantity squared. So at this point, go ahead and take a look at this expression we have, and then go ahead and compare that with what we had on the left side of the expression, and you can go ahead and see that they are indeed equivalent to each other. So that's how I would go about verifying this particular trig identity. If you found this video helpful, please consider giving it a thumbs up and sharing with a friend or classmate that might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.